Hello, everyone. Welcome to another inspiring session of our Modulus Talks. I'm Morgan, your host, and I'm thrilled to have you join us. If this is your first time attending, Modulus Talks is all about educating and informing design industry professionals like you. We explore the latest insights, trends, and innovations to help you elevate your projects and expand your expertise, and this all during your lunch breaks. Today, we'll talk about the innovative solutions that are shaping the world of architectural lighting. Our expert for today is Erika Bafico. She's the founder of Fulcro, an industrial and interior design practice that works on innovative lighting systems and the perception of color. With an international portfolio covering works, exhibitions, publications, and patent pending design system and conferences, she'll share her expertise on innovative lighting solutions in modern architecture, from smart systems to energy efficient and creative lighting applications. So, without further ado, Erica, the stage is yours.
Thank you so much for the invitation to these innovative cycles of talks and webinars. I'm really glad to be here with you in your lunch break, and I'm going to share with you my expertise about innovative lighting solutions for modern spaces. So starting from our connection with light in natural context, our humanity has evolved in relation with the light of sun and during nighttime just of the fire and the moon. This is very important to understand the evolution of human perception of light nowadays. Why? Well, have you ever feel uncomfortable after long hours indoors without natural light? Maybe during a long day at work or waiting in a hospital or in different contexts in which natural light is not accessible and we are disconnected with the natural environment. Well, I guess so, because it makes us feeling a bit stressful and anxious to be in an environment like this, for example, which is very different from the natural context in which humanity has evolved. Actually, we spend 90% of our time indoors. This phenomenon is accentuated by the use of confined spaces, especially in the urban context. For example, underground floors or low floors in densely populated cities, or also building conversions, so factories or sacred or historical places that are converted to other uses. So the windows are not positioned in the specific place that they were thought in the beginning for this use, or also spaces inside of buildings, like hospital waiting rooms, for example, where the patient need to wait for a treatment and maybe you already arrive in this space in an anxious mood and a bit stressful because he doesn't know what he's going to face, and he needs to stay a long time in spaces with this artificial light completely disconnected from the natural environment. So we are always more and more used to this kind of context, and we define this as a normality, which is not. Why? Well, I'd like to introduce my approach talking about the mutability of natural light. Natural light is extremely mutable, extremely changeable during the day, and this is not only providing charm, but it's also creating well-being. It's evident that the time of the day, according to the time of the day, natural light is changing incredibly from the sunset to noon from dawn to noon to sunset, as we all know. But also, natural light changes according to seasonality and to latitude. And also according to the changes in the atmosphere. So when the sky is cloudy, we have a different light coming down to the ground, or even in a special event, like, for example, the dust storm that happened in Greece during last April, in which the sky turned completely yellow for a few hours, or even another special event that happened in last May, when in Europe and North Americas were visible northern lights because of a geomagnetic storm. So these are extreme events, special events, but they commit a visible change in the atmosphere. So I'd like to explore a little bit briefly how the human eye has evolved during the epochs. So our perception of light happens on the retina thanks to photoreceptors. So these photoreceptors are not randomly positioned on the retina, but they are positioned according to specific angles, which are the angle of direct sunlight, the angle of refracted skylight, so the light that is refracted by the sky, by the atmosphere, and the light refracted from the ground. So these photoreceptors are also responsible for the circadian efficacy, which I will show you in a second. And what is interesting is that this efficacy is best recorded in the angle of the refracted skylight. So our connection with the outside is extremely important. The circadian efficacy is the devices responsible for the synchronization of the circadian rhythms are called ganglion cells. They are positioned on the retina. We have different photoreceptors, and these ganglion cells are recently discovered by the science. And what's interesting is that they do not provide images, so we do not see reality, we don't perceive colors, we don't see figures through these cells, but they are just responsible for the synchronization of the biorhythm. And they are also present in blind people's eyes. Okay, so our biorhythms is the synchronization between the internal rhythm of human body with the external rhythm of the sunlight. The variables that are responsible to this synchronization are the time and duration of exposure, the spatial distribution of the light on the retina, as we just saw, and the biological potency, which means the spectral distribution of light and the brightness level, plus the perception of reality. So this synchronization, the so-called circadian rhythms, includes a series of non-visible effects of light. And this is extremely interesting for us, because it means that light do not only permits us to see reality, to see shapes, see colors, and everything, but it also has non-visible effects. This is a matter that has been discovered during last century, is a very recent topic of research in science, and and it has an extreme potential, especially for projects in light design. And it opens up a field that has been called human-centric lighting design. So what are these the effect of this non-visible, let's say, effect of light? Well, first of all is the famous circadian response, which means the release of melatonin and cortisol, which are the hormones that balance our biorhythm, so balance the pressure, the blood pressure, the heartbeat, the temperature of the body. So a set of variables in our biological system. Then we also have increased concentration and reactivity and better quality of sleep. So it means that we have better well-being from a both physical and physiological point of view, which brings long-term health. So concentrating on a lighting design project that includes the non-visible effect of lights provides long-term effects. Examples of projects with this kind of approach are the very interesting lamp developed by Saga Space Architects just a few years ago, which is a circadian light, which is now installed in the international space stations in space. And it's basically a lamp with different emission of light, but also colored light that is emitted in different angles and recalls the natural light. A very special effect is that it's not all day the same, but it also includes random changes like that of weather. Or another example is the system developed by Quelux, which is a lighting device that mimic the sky in a very in a very realistic way. So as you can see from the picture, it looks like we are looking at the sun in a direct, we are under a sun bath in this beautiful blue sky, and is absolutely artificial. But it's perfect to be installed in underground basements or all these places without connection with the outside. Moreover, I would like to talk about daylight architecture, meaning that light not only has non-visible effects, so not only increases our well-being and health, but it also depends upon the geographical place. So daylight is very different according to the place in which we see it, and it shapes also our cultural identity. A few examples in architecture is very simple to understand this concept, looking at the openings in building in relation with altitude. So in the Mediterranean context, we have smaller windows, smaller openings, because of the sun is very strong and very direct with strong contrast. And going north and north, windows became bigger to welcome the direct sunlight, especially during winter time. In terms of projects, architectural project, I'd like to talk about a few examples in Europe, because we can see a very different approach in terms of architectural project and how the natural daylight shapes the identity of the place. The first one is by Carlo Scarpa, which is an Italian architect of last century. And in this image, we see the Gipsoteca di Possagno, where the gypsums by Canova are exhibited with this wall on the background that shows the strong direct sunlight as a background. And what is interesting is that Carlo Scarpa uses the daylight, so the strong and highly contrasted light of Mediterranean context, to create a striking background to these statues. And it's very evident the shape of the sunlight, the shape of light, and the shapes that it creates with the shadows. A very different approach is the one by Alvar Aalto, and he uses the natural daylight in Viipuri, in in Finland to create this beautiful light project for a library. As you can see, it's very different, and the light in this case is very homogeneous. There are no harsh shadow. Everything is lit in a beautifully and homogeneous and a kind of whitish way. And this would not happen if it was in a different context. So I would like to make you imagine what would happen if we switch these two projects. So if the library in Viipuri would be in Mediterranean, we would have a lot of harsh shadow on the ground. While if the Gypsoteca by Carlo Scarpa would be in Northern Europe, we would have a homogeneously lit background without this play of shadows. So the geographical location of architecture is extremely important to be considered in the project in relation with the surfaces of the architecture itself. A last example, a bit different, almost by fun, almost by to try something out of the context. Sverre Fehn decided to realize in Venice a pavilion for the Biennale di Venezia that recreates northern light. So he wanted to create in a Mediterranean context this homogeneous and diffused light typical from the northern Europe. And he did it beautifully thanks to his architecture project. Moreover, I would like to talk a little bit about our perception of reality, because what we see is not always what we perceive, is not always what we see. So I told you before that in the retina we have different photoreceptors that are responsible to perceive reality and also to perceive the non-visible effect of light. Well, the perception of reality is actually a perception, because our photoreceptors transmit the information regarding light to the brain, and our brain reinterprets it. In this image, for example, we see the Ganzfeld effect, which is created by James Turrell, the artist, the well-known artist, in which he creates boundless lens in closed spaces. So thanks to light and thanks to perceptions, the people in the image are feeling has this space has no boundary, while in reality it has. So it's a paradox of perception. A slow recap of how we do perceive colors. We have 3 photoreceptors in the retina, which are each is responsible to receive 1 color each. So it's interesting to think about it, because we do not see all the colors, but we technically see only 1 color, only 3 colors. So only each cone, each of the 3 cones perceives 1 color each. The colors that we actually see are chromatic sensations that are reinterpreted in our brain by additive synthesis. So as you can see on the right side, for example, the light blue is the combination between the information transmitted by the green cone plus the blue cone. The yellow is the additive synthesis between the information received by the red cone plus the green one, and so on. Okay. White light is actually the chromatic sensation by the addition of all the cones. So by additive synthesis, light we perceive it as white. There is a very interesting example about perception made by Goethe. So he was working not only in theater, but he was working a lot about the perception of light and perception of colors. And I want to share it with you because I think it's very, very interesting. The relation between light and surfaces in this case. So as we can see in the slide, we have a cone illuminated by two sources of white light, and it results with two gray shadows. Then Goethe turned on just the left light, putting a green filter on it. Of course, the result is that we have only one shadow, and it is gray, dark gray. What's interesting is what happens when Goethe turn on the right light. So imagine we keep the left light with a green filter, and now we are going to turn on the right light in a white light. Okay, so we see a colored shadow, a green shadow plus a pink shadow. In reality, the pink shadow is not existing, so the shadow is not emitting a colored light spectrum. I don't want to go too much in technical, but the right shadow, we perceive it as pink, but in reality is actually gray. What is happening is that our brain is putting a complementary color to green on the opposite shadow. You could try these experiments also by yourself at home, using a colored light, a green light, and a white light, and putting them towards an object. The use of colored light to induce a different perception are widely spread. Of course, it's very, very common, of course, in all flights, in all the airplanes. I guess you all have experienced it. I'm showing here the two, in my opinion, best examples, which are the Island Air, which recreates the northern lights, and they even move, and the Emirates Air, which is very, very elegant and very well done, and it even has the stars. Moreover, not only in transportation, but also in healthcare, the perception of to induce a different perception through colored light is widely used. For example, in this case, is spectral CT is a technical equipment for a TAC by Philips Healthcare, and as you can see, the color in the room changes according to the time of the visit of the person, to make it calm, to make it relax, to feel at ease during the visit. Another example of use of colored lights and color surface in the hospital is this children hospital in Arizona, which in terms of lighting and architecture is one of the best examples that have been done so far. I found, so as you can understand, I'm really passionate about the relation between light and surfaces, and I found really interesting, I would like to share with you this quote by Ettore Sottsass, an Italian architect by last century, who says, "From the idea of surface as a solid tool to mark a limit, to seal a space, we can move on to the idea of surface as a light deposit, as a tool to expand space, to open it, not to define it, and let the gaze cross its borders. Light, colored light, have no solidity, have an evanescent, uncertain, mobile, and untouchable presence. The design of uncertain spaces, mobile, physically and culturally crossable, perhaps responds to new existential needs." And I can totally agree with this quote. So basically, let's go a little bit in technical. What happens when a surface is lit? Well, the light coming from the surface is just light re-emitted. So when the spectrum of light touches the surface, some of the energy, so light is energy, some of the energy is absorbed and some is re-emitted. So what we see, the colors, are the result between this relation of the emission spectrum and the surface itself. For example, the work of Liz West about these amazing dichroic filters, we can understand this concept very easily. We see all this color shape coming from the floor. The floor is colored, has all this dichroic filter that re-emits the light received up to the ceiling. And coming back to the technical spectrum diagrams, we know that white light re-emit white surfaces re-emit the totality of light received, while black surfaces absorb all the light received completely. For example, a black car parked during summertime becomes very warm. Okay. Following this concept, is very interesting to notice that in Pompeii, ancient Romans were building roads using white stones to enhance nighttime visibility, as you can see in this picture, because of this concept. So because the white stones were re-emitting almost the totality of light received. So they could have a little bit of nighttime visibility in the roads. Another example of the light coming from floors is this beautifully lit canopy. So the orange, let's say, part of ceiling is lit just by the reflection of light coming from the floor. So the light sources are here, they bounce on the floor and they go up to the ceiling to lit it up. Then below white light, so we can understand that white re-emits almost the totality of energy received, and each color has its own re-emission spectrum. So this means that under white light, this color red, which is a surface, so a surface of this color, will re-emit the spectrum with this shape. This similarly works for this other color. So this light blue below white light will re-emit this kind of spectrum, and we will see it blue. Okay. This happens below white light, but probably you have experienced as well, like me, that when I buy something from the supermarket, especially a meat, something reddish, and I bring it home, the feeling is different. Why? Because most of the supermarkets nowadays have a lighting design project that is able to enhance specific colors. So the vegetables are lit by special lights that make green more evident. Same for the meat and the bananas and the rest. So every part of the supermarket is lit with the emission spectrum that enhances specific colors to make the products more appealing to us. As you can see in this picture, the samples that I was bringing on top, they are changing, but they are actually always the same. This happens below different lights. What is happening? I'm bringing you this slide of measurements. So as you can see, as you can notice in here, there is an objective change. It's not just a perception, but there is an objective change in this case. And the change is due to the fact that every color, as mentioned, has its own re-emission spectrum. so like this. And this re-emission spectrum that is characteristic of each surface is combined with the energy of the light that hits it, resulting in a relative re-emission spectrum and therefore a different perception of color. So in this example, the color, the purple, combined with the specific light emission, cannot re-emit the amount of energy A, and therefore the colored surface will look different to us. Okay, a little bit more practical part. What do you see here? Well, I can't see your answers, but I guess that you will see, like me, a color, a surface that is slightly different in two colors, up and down, but they're very, very similar with each other. Brownish, oranges, quite similar, but not okay. Well, this is what we see under sunlight, and this on the right side is what we see under an incandescent lamp. Is the same surfaces, is the same surface, but we perceive it extremely different. This is exactly what happens with this re-emission spectra in relation with the specific light emission, and is called metamerism. So metamerism is a phenomenon when two colors appear similar under a certain light, although their spectral composition is different. This happens when the barycenters of their absolute re-emission spectra are placed in the same position. So for example, this green color that I'm showing in the slide is perceived similar under specific light. This effect, the metamerism, is now absolutely avoided by the industry because make the color, the surface, extremely changeable. So the surface with enriched spectrum, the example on the top, as you can see, the spectrum is really has peaks of colors. So it's extremely changeable under different illumination. The surface will change the color that we see, while the industrial mixture that we see on the bottom part of the slides are industrial mixtures, so they have the re-emission spectrum quite flat, which means that under different light conditions, the color will look the same, okay? And this is exactly what industry nowadays looks for. Imagine, for example, in the automotive sector, if a car needs to change the door, okay? Then the door is replaced and the people is driving under sunlight and is perfectly fine. All the car looks the same. But as soon as you go into a garage and there is a different condition of light, the door, which is the only new part, will look with a different color to the rest. Okay, this is not something that is desirable. So the industry in general try to avoid metamerism. But I found it extremely interesting. I'm actually working on this phenomenon because it's something that I believe is very fascinating. It's really mimicry in nature. The Jørgen Törnqvist, for example, is one of the color theorists that mostly use the effect of metamerism. And in this image, you can see his project for Brescia Thermolauser, so this tower that is treated with different surface, with the surface of this tower is treated in different ways to let's say be always to disappear in a way with the skylight, so to be as more similar as possible with the changes on the blue sky. So let's going back to the beginning. Do you ever feel uncomfortable after long hours indoors without natural light? Well, nowadays we can design light in relation with all these new advancements and innovation that I've been talking to you, and providing interior exteriority, which is a term I really love. It's come from Alvar Aalto, and it's basically the concept of bringing the exterior environment indoors. How? Well, I'm working on this phenomenon with the reproduction of the sky, and I want to share briefly with you this project of mine. In the skylight is the result of the scattering of Rayleigh, which is the phenomenon thanks to which we see the sky colored. So it's a refraction of very small molecules. And I'm working on a system which is called Aura Blue. It's a site-specific lighting device that simulates human physiological biorhythm during stays in confined places by reproducing the sky. How? Through three components: a light source, a re-emission surfaces treated with a special finish enhancing variables like metamerism, and an intelligent control. The intelligent control makes possible to create site-specific scenarios according to the geography, so the latitude and all the variables that we saw before, to recreate inside places scenarios that are continuously changing during day by day. For example, in Helsinki, you see on the left side the parameters of the place itself, and on the right side what would happen in the lighting scenarios. This is quite similar but different in Miami case, in which the contrasts are more marked, so the scenarios will be different, the artificial scenarios. What happens then on the surface of the room? Well, each surface is treated with a special system, and will have different outcomes during the day. So on the east wall, we will see the sun going up, but in a very abstract way. And throughout the passage of time, at noon, we have this kind of scenarios, and then in the 5 p.m. and the end of the working day, the sunset will be visible on the west wall. Okay, so this system I've been working on during last year, is now patent pending, and it recreates the perception of outer space indoors. So enhancing our biorhythm, reconnecting us with the exterior places and with natural passage of time through light. Is a system that produces indirect ambient light and do not exclude other sources of light. A simulation of an exhibition for the application of the system in different contexts, so we could have it as a very immersive and abstract, in a very immersive corridor, and then we could apply it on the complete length of the wall or in portions. And I would like to show you what would happen if we visit this hypothetical pavilion in which each room is positioned in different location with different uses, always related to office. So in this case, it's the scenario for London in 3 p.m. And as you could see, the geographical orientation is quite important. If we cross the door and we go to the next room, it's a meeting room and it's hypothetically located in Helsinki, we would have a scenario that is closer to the sunset. Moreover, we could go to the phone booth to make a call. Hypothetically, it's located in New York, so with a different time zone will be morning time. It's quite interesting to think also to the light and the reflection of light on surfaces in places very, very small, which are for sure confined spaces without connection with natural light, and in which we could spend quite a few hours, for example, for a phone, for a call or a meeting during working time. And then, for example, we cross the room and we go to Sydney, in which is night, and we would see the system switched off with finishing on the wall that will be visible. Aura Blue is a patent pending product that I've been working on. It's a research project which now is also available. And to conclude, I would like to say that observing the sky is a unique experience, and to me is an endless source of wonder as well. Thank you very much.
Thank you so much, Erica, for this enlightening talk. It has truly inspired and taught us a lot on what's new in architecture lighting. So let's start our Q&A. So I have a first question. How does energy efficiency play a role in modern lighting design?
Yeah, energy efficiency, I think, is a crucial point of modern lighting. We are using, in terms of technology, lighting devices are experiencing a very fast change. So we are using nowadays LED, which are extremely efficient in terms of energy consumptions. But I think that it's also very important to consider the effects of light in terms of wellness, and so efficiency is both a matter of energy consumption and also well-being, human well-being in the places.
Okay, I was muted, sorry. Next question. What techniques are covered for integrating lighting with architectural features?
So it's very, very interesting nowadays to work with light, because thanks to technology and innovation, the light sources are becoming smaller and smaller. So we could integrate it really anywhere. The miniaturization of light source is a very powerful tool for us as architects, lighting designers, because it makes possible to integrate light source in literally every corner of the architecture, and even in dresses and so on. And I think that also is very important to consider the light coming from the outside, so natural light, in order to integrate, to balance the artificial and the natural lighting in buildings, and also to integrate controllers and other smart systems that can automatize the illumination, the artificial illumination, and balance it with the outside.
And how can, yeah, I'm not muted. So how can smart lighting systems improve the functionality of a space?
Sorry, lighting systems?
How can smart lighting systems improve the functionality of a space?
Yeah, I think this is it's extremely powerful in lighting, because as we saw from the slides, a space completely changes with lights, and light is something immaterial. So we could change literally the perception of space just turning on a lamp. And thinking about this is giving us, as designers and architects, a very powerful toolkit to implement in the project.
Okay, so and how can I apply these innovative lighting solutions to my projects?
Well, every project is different, and it's but in general, applying this is thinking about the well-being of the people living in the space, and integrate and trying to imitate as much as possible the natural light, which is always the good one, I would say, in an intelligent way, so avoiding high consumption of energy. And yeah.
Okay, so thank you. I think that's it for the time that we have for today. Thank you all for your questions. If your question didn't get answered, no worries. We'll send a full Q&A after the session via email together with the recording of this talk. I want to thank everyone for joining, and thank you, Erica, for this amazing talk. And if you haven't signed up yet for our next Modulus talk in this series, be sure to do it, because we'll be joined by two experts, Kimberly Bartlett and Alice Sanduch from Introba. They will talk about lighting as an artistic element in design. So thank you, Erica, and everyone, and see you next time. Bye-bye.
Thank you very much.
Bye.